analysis, which is natural language processing based analysis. Natural language processing based text analysis is what we are going to get started with. Okay. And also this is something very, very, very common and very widely used today, which is called as sentiment analysis, right? Now, what do you mean by sentiment analysis? Guys, you might have seen that there are say thousands and thousands of tweets that come in every day. Suppose if something has happened, say suppose a new movie has released, there might be thousands or maybe lakhs of people talking about that particular movie, lakhs of people giving you their reviews of this movie. Some of them would be positive, some of them would be negative. How do you understand the sentiment? When I say how do you understand the sentiment, what I mean is, say if about 1 million people have spoken about or written about that particular movie, how do we know whether they are positive or negative, or whether they're liking the movie or whether they are not liking the movie? Okay, let's go to this little exercise. Now, this was a movie which was released some time back. This is Avengers the Endgame. How many of you have seen this movie? Honestly, I have not. I've never been a big Avengers fan or something, so I haven't seen any of the movies of the series. How many of you have seen this movie? Nobody? Okay, just one person. This was supposed to be a mega hit. Okay. Now, all those who've seen this movie, did you like it or not? Did you like this movie? Yes. Mm, okay, fine. Okay, fair enough. Now, what you see on your screen are the 5 actual reviews that were published regarding this particular movie from different platforms, from Rolling Stone to Common Sense Media to Behind Woods to Wall Street Journal to wherever, right? Quickly, maybe not more than 2 minutes, just read through these reviews and please tell me, in the context of the movie, are these reviews positive or are these reviews negative? Just read all 5 reviews and tell me whether the reviews are positive or the reviews are negative. Okay, yes. Are the reviews positive or negative? Positive. Okay, almost all of you saying positive. That means almost all reviews are telling you that the movie is good, right? So that is what it is. Fine. Now over here, I had 5 reviews from 5 different places or five different publications, and I just wanted to know that what are these publications generally thinking about this movie. And what you find is that all of them are saying that the movie is good, or all of them are saying that this is positive, right? The argument now is, please, suppose there are, say if I go to Twitter, this movie has released, there are 1 million people who have written something about this particular movie, and now I need to understand, of the 1 million reviews that we have, what is this, what is the scenario? Are people liking the movie or not? Now how do I do that? Now, do you think it is actually possible for someone to actually sit down and read all 1 million reviews and then come up with some conclusion? Or maybe say 1 million is 10 lakhs. So is it possible that someone actually sits down and then the person reads through all 10 lakh reviews and says, okay, 8 lakhs say that the movie is good and 2 lakhs say that the movie is bad? Is it practically possible? No, practically, one, it is not possible, and second, even if somebody tries to do it, you can imagine the amount of time that it will take, right? So it is just not feasible. But what we see is that in spite of so much of digital data, in spite of so much of activity on the social media, we still get that we still get the sentiment so quickly, right? We get to know immediately, okay, people are saying bad about this, people are saying good about this, and so on, something like that. Now, how does that happen over here? Or maybe every now and then you'll find that this hashtag is trending on Twitter. Now, there are millions and millions of people who are commenting about things, different things on Twitter. Then how is it that you get to know so quickly about what is trending and what is not? Right. So all these things, how does this happen? All this will come under part of, say, sentiment analysis, where Bayes theorem will have a huge role to play. Now, let us first try and understand the concept behind, say the naive Bayes theorem. We'll see the limitations of this Bayes theorem, and then obviously we'll understand the terms, the mathematics behind the naive Bayes theorem, and then I'll demonstrate this with the help of a program. Now, this is a classic case of an ML algorithm where you'll see a program which is pretty lengthy, and then you'll realize again that 80% of the code is never going to change. See, the funda is simple. The processing that happens in Bayes theorem will remain the same irrespective of what is the data that you are feeding it. So what you do is you will always treat all those codes as black boxes, because see, the algorithm, the concept doesn't change. Just feed the data that you want and it will keep giving you the desired results, right? Okay. Now, how does this theorem work, and what is the limitation? And then we'll also try and understand why is it called as naive Bayes theorem. Understand? See, suppose if I say this is a bad movie. Now, please tell me, if I'm talking about some particular movie and say if this is my review, please tell me this review is positive or negative. Quickly, this is a bad movie. This review is negative. Okay. Okay, guys, all of you telling me that this review is a negative one. What makes you say, or how did you come to this conclusion that this review is a negative one? What was the thought process, or how did you analyze it? Yes, because of this word called bad. So because of this word bad, you understand that this is negative, or this is the problem that we have, right? Now, what your Bayes theorem will do is it will analyze these words, and the way we looked at the words and we knew that this word bad actually is a negative term, or saying that the movie is not good, so we said, okay, this review is negative. Now, that is exactly what your Bayes theorem will do. It will go on this concept of tokenization. What do you mean by tokenization? Tokenization means that whatever is the data that you have, you just convert it into separate words. Words are called as tokens in programming, and then you analyze those words, you analyze those words, and you analyze those tokens, and you analyze those tokens, and then come to whatever is the conclusion required. So that is what it is, right? Okay, but then observe this. Now, with reference to the movie, please tell me, is this review positive or negative? This is my review. Positive, positive. Okay. Now, guys, observe this. When I wrote the previous statement, all of you told me that this review is negative. Now, most of you are telling me that this is positive. Some of you are saying this is neutral, right? Now, guys, understand this. The problem with Bayes theorem is that it is naive. What do you mean by this word naive? What does this mean? What does this mean? Naive basically means immature. Immature. Now, why is it called as, yeah, innocent? True. So why is it called as a naive Bayes algorithm? Now, the problem here is the Bayes theorem will work on the concept of tokenization. So it will see this particular word bad and it will say that, okay, this is a negative review. The point is, even in this particular statement, it will see this word bad and it will say that this is a negative review. What the Bayes theorem cannot do is it cannot find the correlation between the words like this. Actually speaking, this is not that bad a movie. If you understand the context in which I'm using bad in the second statement, it is actually negating the negative aspect of this word bad. But then this is something which your Bayes theorem will not be able to pick up. That is why it is called as the naive Bayes theorem. So you can trick it into giving you wrong answers, but that is unless someone is really trying to do that, or unless someone is using like this where tokenization is just not working. That is where it'll have a problem. So that is what is the limitation of your naive Bayes theorem. That is the precisely the reason why it is called as naive. It will work on the concept of tokenization, and based on the tokenization, it will give you the answer. Now, suppose what I do is I now design an algorithm which also takes into account the correlation and stuff, everything. Suppose if I do that, the question is, when we know that there is this particular limitation, or there is this particular limitation, then why is it that the naive Bayes theorem is still so very popular, and why is it that it is still being used in practical application design? Guys, understand this. The reason is, first and foremost, practically speaking, most people will speak like this or write like this. Very few will write like this. If you had liked this movie, you will say this is a decent movie, this is a good movie, this is an okay movie. How many of you will actually say that this is not that bad a movie, right? So most of the language that is spoken or written is not written in the manner in which I've written the second statement. So this is one aspect, right? And second is, even if I have an algorithm which is trying to find the correlation and everything, it'll involve something called as parsing and stuff. Imagine with millions and millions and millions of data that is getting posted or on Twitter or on social media or digital data wherever, digital data wherever. What happens over there is, digital data. Even if I have an algorithm and if I try to analyze, say, the tokens and the correlation with all the words, it is not going to be possible, because it will increase the processing time, it will increase the amount of processing required, say maybe n number of times, which is practically not feasible. So because of these two reasons, we found that naive Bayes theorem, with all its limitations, it's still a pretty decent algorithm when it comes to sentiment analysis. And guys, sentiment analysis is something which is very, very, very popular with digital data today. Literally, social media is all about sentiment analysis, right? Okay, understand this. What's happening out here now? Uh, Guys, see, just recently there was this Tanishq ad which generated a lot of controversy, right? How many of you saw that ad? There's a huge controversy over that Tanishq ad just recently. Just two people, others? Okay. Now, moment that particular ad was released, there was a lot of controversy. There were a lot of people posting about pushing their thoughts about that particular ad. We saw it on Facebook, we saw it on Insta, we saw it at so many places. I'm sure you would have seen that in your friend list or on your Facebook feed. Please tell me, see, of all the people who were talking about that particular ad, were they in support of that ad or were they against that ad? What is your general opinion in your friend circle, or the people who were posting on FB and all? Were they in support of that ad or were they against that particular ad? Okay. Now, see, you might have seen, say, maybe 10 or 20 people talking about that particular issue on your social media feeds. Yes, there would be some people who would say, no, 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 this is wrong. What they're showing is wrong. They're against. Then there would be people who said, no, what is wrong in that ad? I did not find anything objectionable, this, that, whatever. So you actually saw those ads, and see, my personal observation is, if I had to put a number to it, it was about, say, say 90% people were in support of that particular ad. They did not find anything objectionable. And yes, there were a group of people, say 10% people, who saw something wrong with that ad. So that is okay. Guys, understand this. What the company would have done is, company would have immediately carried out, say, some kind of a sentiment analysis, and then try to come up with some conclusion about what needs to be done. The another controversy that has happened was, immediately what Tanishq did is, they just pulled down the ad. So the experts, they came in support, saying that had they carried out a proper sentiment analysis, they would have found that that ad has got a lot of support from people. But why is it that they just pull down the ad? So that is what even the experts did not like about Tanishq, that they were too they were in too much rush where they pulled down the ad, whereas the sentiment analysis would have helped them to understand that most of the people who spoke about that ad were actually speaking in support of that particular ad. So that is where sentiment analysis comes into picture. Literally every day, anything that is posted on any of the social media feeds or wherever, you will find that companies will carry out say drastic sentiment analysis for that. Okay, now how does this work? Let us try and understand. So what we need to understand is the concept behind the Bayes theorem. Currently we are just trying to understand why Bayes theorem is required and how is it going to help us in sentiment analysis. Now, how exactly does this work? Now guys, understand this. The whole concept of Bayes theorem, it works on the concept of posterior probability. Now guys, I want you all to understand I want you all to understand the concept of the hypothesis and evidence and data. We'll understand posterior probability. We will see with an example how does the Bayes theorem calculate these probabilities, and then obviously when I go to this program, again you will find our favorite fit function, which will do everything for us. We will not be required to get into these details when we come to programming part. Okay, first of all, let us understand a couple of words. First is H, or whenever I use this word H in programming, we always talk about hypothesis. H represents hypothesis. Now, what is hypothesis? Guys, suppose if I say it will rain today in the evening, suppose I made a statement. It will rain today in the evening. That is the statement that I make. Now, any statement that I make, or any statement which is trying to convey some information, is a hypothesis, right? Okay. Now guys, I make a statement. It is going to rain in the evening today. How many of you will believe this hypothesis? And how many of you will say, no, kuch bhi bolta hai, it won't? How many of you believe this hypothesis that it will rain today? Because just I'm saying. And how many of you say that no, it's not going to rain today? How many of you? Believe or not believe? Believe. Guys, you can put it in the chat window, so you can unmute and speak as well. Believe. Not believe. Okay. This obviously, this is what will happen if I give a hypothesis like this, that it is going to rain in the evening today. So some of you will believe and some of you will not believe. True. All those who believe, can you give me the reason why is it that you believe this statement that I make? And similarly, all those who say that I'll not believe, what is the reason, or what makes you not believe to what I say? What's the reason? Weather conditions. Okay. So because of weather conditions, you won't, okay, you would believe. I think apparently it has been raining very heavily in Hyderabad and around Hyderabad. So I guess people who are in and around, say, Hyderabad or Telangana, they might believe it. Now, looking at the climate here in Mumbai, I don't think, if somebody had told me that it is going to rain today, so I don't think I would believe that, because in Mumbai it doesn't look like. And now, depending on whichever places you are in, I think we have people from across India in this group. So depending on where exactly you belong to, you may believe or you may not believe. See, the fact is, when I say a hypothesis, I've just made a statement that it is going to rain in the evening today. This is just a hypothesis. There is absolutely no justification given to this statement. So even if you try to, you will not be able to come up with a reason why to believe what this fellow says or why not to believe what this fellow says, right? See, because a hypothesis could be any statement. A hypothesis, whether it needs to be believed or not, depends on the evidence or the data. So data is the evidence. So whenever I say D over here, this is data, or actually speaking, in terms of artificial intelligence, the right word is actually not data. The right word is evidence, right? Now, suppose if I tell you, guys, it's very overcast today. It's almost dark now, right? I'd say 11 in the morning. It's almost dark. It's extremely overcast. I think it is going to rain today. Now, guys, just observe this. I've given a hypothesis again that it is going to rain, say today. I've given this hypothesis, but now I have given you a data. I've given you an evidence that, okay, it is extremely overcast. It is almost dark at 11 a.m. in the morning, which generally does not happen, right? So you can see this particular data. Now, if I give you the data, most of you would end up believing my hypothesis. But suppose if I tell you it is going to rain today, and my data or the evidence is that currently the temperature here is 35 degrees, it is bright sunshine, this is not rainy season. If I give you this data and if I give you these evidences, in that case, the hypothesis, most of you will say that no, then how is it going to rain? So precisely it is the data or the strength of the data or the evidence that will actually give us the probability of the hypothesis being true. So when I say I'm calculating the posterior probability of H in presence of D, what it means is, what is the probability of the hypothesis H being true in presence of the data or evidence D, right? So that is what is the posterior probability. So suppose if my hypothesis is that it is going to rain today, right? And say suppose my data is that it is overcast, it has been raining for the last 3 days, maybe it is almost dark, and there is a warning from, say, the department, right? The department which predicts the rains, there is a warning from them. If I give you all these evidences, you will say yes, then it might rain. So the probability would be as high as, say, 0.9%. It is still possible that 0.1%, 0.1% it may not rain. Now, suppose if I say the hypothesis is that it is going to rain today, and my data is that the temperature is 35 degrees, it is bright sunshine, it hasn't rained in last 1 week, the rainy season is gone. Now my data is going very much against the hypothesis, so I'll say that the probability of it raining is 0.1% and it not raining is 0.9%. So we are always calculating the posterior probability. What is posterior probability? Posterior probability is the probability of the hypothesis H being true given the data D. In presence of data D, the probability of this hypothesis H being true. Now, for calculating this, I need three things. What are the three things that I need? First is the probability of the data knowing that the hypothesis is true. Now, it is the reverse one. Suppose if I tell you that it is going to rain today, based on that it has been raining for a week, it is completely dark outside, and say it is overcast. Now we'll see reverse. Now, assuming that this hypothesis that it is raining is true, assuming that this is true, then what are the chances that it is overcast? So I know whenever it rains, it is overcast. This hypothesis being true that it is raining today, then what is the probability that it has been raining for last 5 days? So generally what I find is that if it has rained for 5 days, little bit it will rain on sixth day as well. So we will see that whenever this hypothesis is true, assuming that this hypothesis is true, what is the probability that you'll find the data? So this is actually giving you the understanding about how strong the evidence is, right? Okay. Probability of the hypothesis H being true irrespective of the data. suppose if I don't give you the data, and if I just tell you that okay, it is going to rain today, what is the probability of this being true in a presence or absence of that particular data? I don't care about the data. And what is the probability of this data existing irrespective of the hypothesis? Like I told you that it is dark outside, right? It could be it's not related to rain. Maybe it's just this, that it's nighttime, and nighttime generally it's always dark outside, so that could be the reason. I never told you that it is day and it is overcast. So we will look at these four probabilities, substitute them in the formula, and then we'll get the answer. So entire naive Bayes theorem is going to be working on this formula of posterior probability. Now what I'm going to show you now is, when we go for sentiment analysis, how do we calculate the posterior probability? Okay, let's try and understand the posterior probability. Guys, understand this. Now let's take up a little example. Please listen to this very carefully, because see, you will suddenly see that there's such a huge program and there are so many different functions. But this example that I discuss in the next 15 minutes, if you understand this, guys, I mean it when I say this, the program that I'll give you for the Bayes theorem, 80% program, you will not be required to touch. Whatever I'm discussing will happen automatically in that particular function. Now observe. Let's take up this example. Say I'm planning to carry out some kind of analysis over here. Suppose I have this data where I have 5 statements. I want to identify whether whenever somebody makes a statement, I want to identify whether this statement is related to sports or not. That is what is there. So the statements that I have are: first is a great game, which we identified as something related to sports. The election was over, which we have identified, no, not sports. Clean match, very clean match, sports. A clean but forgettable game, yes, about sports. It was a close election, this is not sports. So suppose this is the data using which I'm going to be training my model. Obviously 5 values are very less for sentiment analysis kind of thing, or text analysis. But now suppose somebody makes a statement, a very close game. Now I want my system to come and predict whether this statement is about sports or not. So what am I going to do? I have these 5 statements. I've analyzed and I've understood that out of these 5, 3 statements that I've tick marked, they are pertaining to sports, or they are talking about sports, and the other 2, they are not talking about sports. The aim now is to just understand whenever somebody makes a statement, my system has to be able to classify this as, say, about sports or not about sports. So that is what we intend to do. Guys, from here, I'm now diving deep into the concepts of Bayes theorem. Any doubts with whatever we've discussed so far? Because now I'm going to get into the mathematics of the naive Bayes theorem. Any doubts with this? What are we trying to do? Hope all is okay. Okay. So let us try and understand how this is going to work. Now, guys, the biggest problem over here is that whenever we talk about probabilities is all about numbers. So for me to be able to calculate the probability, I'm going to calculate the probability of anything. I need numbers for that, right? The problem over here is I'm dealing with text. If you see, I'm dealing with text everywhere. So I don't have numbers. Now, the problem is, if I want numbers to calculate the probabilities, then how do we go about doing that? Now, guys, please understand this. Let's take up a little example over here. See, guys, currently say there is this the IPL season going on, IPL matches are going on. You might be coming across so many different articles, so many different shows pertaining to IPL. It could be on social media, it could be written, it could be say some recorded videos or something. Can you give me the words which you will come across most of the time when the news is about IPL? What are the words that you'll come across, maybe in the news that you read, or maybe what you listen to, or whatever? What are the words that you will come across frequently when you and you know that it is about IPL? Okay, the sponsor name, IPL, match, innings. Okay. What are the words? Suppose if you're reading, say, 5 articles related to say IPL, what are the words that you will find, say, in almost all 5 articles? Okay, scores. What else? RCB won or loss. Okay. The team names, obviously. Orange cap, yes. Runs, fine. Purple cap, overs, true. Overs, runs, wickets, fine. So, guys, if you understand this carefully, see, generally, when you read, say, the sports columns, or generally when you read the newspapers, it's not that these words are not there. These words are always there. But understand, when it is about IPL or during this IPL season, you will come across these words even more. Now, see, suppose if I'm reading an article and if the article says, say, Mumbai Indians. Now, moment they say Mumbai Indians, I know that 100% this is related to IPL, because understand the term Mumbai Indians is relative, or is important only in the context of IPL. Apart from that, if not for IPL, the term Mumbai Indians has absolutely no significance, right? So I can very conveniently say that moment I see, say, the word Mumbai Indians or the name of any of these IPL franchises, I can say that yes, this is about IPL. But understand this. Say when India is playing, say, cricket, if I see this word India in the newspaper, it does not necessarily mean that it is pertaining to cricket. Agreed that currently India is playing, say, a cricket series against someone. But understand there are thousands of other things that we can speak about when I use the word India. So it's a very remote possibility that it is about the Indian team or Indian sports, not necessary. But when I say Mumbai Indians, I know that okay, this particular word is pertaining to IPL only. So guys, understand this. Whenever you talk about something or you talk about certain context, there would be certain words which will appear more. There would be certain words which will not appear much. And that is what is called as the frequency of the tokens. So what your naive Bayes theorem does is it relies heavily on the frequency of the tokens or the frequency of the words that are being used, and based on that it is going to calculate the probabilities. So guys, I would be relying heavily on the frequency of words, right? Okay, observe this. Now, suppose if I've been given this particular statement, a very close game, and I want to say whether it is pertaining to sports or not. So the posterior probability that I'm required to calculate is what is the probability that this data, a very close game, is related to sports. So the data is a very close game, this sentence, and sports is the conclusion that I want to make, whether it is pertaining to sports or not. Suppose if I get 85% probability that yes, it is pertaining to sports, then I'll say that yes, this statement is pertaining to sports. If I get, say, 9% probability that it is pertaining to sports, so what this will mean is that this is not pertaining to sports. Guys, please understand this. I need to get, say, both the probabilities and then try and get the answer. Now, how do we get these probabilities? Just understand this, guys. Don't get intimidated with the mathematics that you see now, because all this will happen in the background, right? Okay. So now suppose I'm planning to go with the frequency of terms, the frequency of words, and then I'm going to make certain calculations based on that. Now, how do I get started? There are 4 steps that you need to understand whenever you think about the implementation of the naive Bayes theorem, right? Okay, guys, let's put it like this. Suppose, say, suppose my weight is 100 kgs. You are, say, some nutritionist, you are some, say, fitness expert, someone. I have come to consult you and I told you that I want you to help me with weight loss. Okay, you are an expert, say, fitness consultant or nutritionist or whatever. I'm someone, a potential client. I've come to you and I'm telling you my weight is 100 kgs. I want you to help me in reducing this weight. Guys, what are the questions that you'll ask me before you get started? As an expert or consultant, what are the questions that you'll ask me before we get started? Yes, I need one question each from everyone in the chat window. Okay, age is one factor, one question. Yes. Height and age. Okay. Medical history, health issues. Yes. Important. Eating habits, current weight, lifestyle. Fine. Others. Okay. Nature of work, profession. Okay. Fair enough. So these are the questions that you would ask me, and rightly so. Now, guys, none of you asked me what is my favorite color. None of you asked me what is my favorite color. Why? Why you all didn't ask me what is my favorite color? Obviously, na, it has got nothing to do with whatever you are trying to solve. You are planning to help me in my weight loss, and my favorite color doesn't help you in any given way. Now, even if I tell you, okay, my favorite color is say red, right? Even if you have that information, you will any which ways not be able to use that information. So why have it? Similarly, guys, please understand this. When I go for sentiment analysis, or when I go for text analysis or natural language processing, understand natural language processing. What do you mean by NLP? Natural language processing basically talks about the speech that we use. So while we are talking or while we are writing, as a layman, the way I speak, the way I write, or what I write, that is what is natural language. Natural language processing. Our language will always have a lot of stuff which is actually not which is actually not required. If you analyze the way you talk or the words that you use while talking, there would be a lot of extra stuff which is actually not required, right? So what I need to first do is, whenever I'm analyzing something, I need to carry out something called as feature engineering. Feature engineering precisely is picking out the relevant data, or picking up only that data which is pertaining to whatever we plan to do, or whatever we are planning to resolve, right? So that is what is feature engineering. So guys, when you ask me this question, what is your age, what is your height, what are your eating habits, there's that was feature engineering. You knew that, okay, asking the color in this context doesn't make sense, so you never bother to ask me, because even if you had that information with you, it is not going to help you. So guys, the first thing that you need to do is feature engineering. You need to first pick and choose what are the things which are relevant to whatever you're talking about. So when you just spoke about IPL, when I asked you what are the words that you come across, so you said the names of the franchisee names, or score, or maybe say overs or runs or sixes. See, this is feature engineering. You picked up those words which you know, which appear frequently when you talk about, say, an IPL game. So that the answer that you gave me was feature engineering. But now understand this, still using that feature engineering, or once I get the frequency, how am I going to calculate the Bayes theorem? Now observe this. For me to be able to get this posterior probability, a very close game, I want to tell that this statement, whether it is about sports or not, if I want to calculate this probability going by the naive Bayes formula, it is the probability of somebody using this statement, a very close game, whenever they are talking about sports. What is the probability of this being true, if this is true, versus what is the probability of something being about sports, and what is the probability of someone using this particular algorithm, sorry, this particular statement. Guys, if I can get some values over here, suppose if I get 5 multiplied by say 10 divided by say 70, then maybe I'll get the probability. I need numbers. The problem is, how do I get numbers? Because I'm working with words, I'm working with tokens over here. Now guys, just observe this. How is this going to be done? See, first and foremost, over here, I just want to come up and tell you whether this is about sports or whether this is not about sports. That's it. That is what I'm required to tell. By what factor is it about sports, or by what factor is it not about sports? I'm not interested in that. So that is why I can actually ignore this. This actually helps me in getting the factor. Over here, all I'm required to tell you is whether it is about sports or not. So just numerator is going to be good enough for me to get the answer. But the question is, even if I look at just the numerator, how am I going to get these probabilities? How do I calculate this? Now, this is where I'm going to be using I'm going to be using the frequency factor. Observe this. Let's take an example. See, if I say of, say, close. So what this means is, what is the probability of me using this word? But then understand, when you say a sentence is a combination of words, na? So how do I calculate this probability? So guys, observe this. Probability of this statement, a very close game, is the probability of we using A, probability of we using this, the probability, or the products of the probabilities of each of the words is going to give me the probability of this particular sentence. So that is what we need to do. Is this understood, please? But I'm not just interested in this. I'm interested in the probability of this with reference to sports. So what I'll do is, so the probability of this statement with reference to sports is the probabilities divided by sports. Basically, all I've done is I've divided it with the probability of sports on both the sides. So that is how it is going to happen. So guys, it's pretty simple. For me to get this, I'll just erase everything. For me to get this value, I basically need to get this value. Once I get this, I will get my answer. This, and in which ways I'm not interested. But for me to be able to get this, I need all these values, right? So once I get all these values, I will be able to calculate this. But I want to get this statement with reference to sports. I'm not looking at this statement independently. This is with reference to sports. So basically, I want the probability. I want these probabilities. अब ये क्या है? देखिए, this is the probability of we using this word when we are talking about sports. When we are talking about sports, what is the probability that we use very? What is the probability of sports that when we talk about close? What is the probability of sports when we talk about, sorry. What is the probability of using this word game when we talk about sports? What is the probability of using word close when we talk about sports? And so on. That is how this is going to work. Now, how do I calculate the probabilities? Let us try and understand. Now, I'll start with one word. What is the probability of anybody talking about sports? Now over here, I have 5 statements. 1, 2, 3 are about sports. So the probability of someone talking about sports is 3.5. 3 on 5, 3 out of 5. What is the probability of we not talking about sports? So out of the 5 values that we have, 2 are not about sports. So it is 2 or 5. This is what we get over here. Now, we need to get the probability of each of these words whenever we are talking about sports. So how do I do that? What is the probability of we using this word game when we talk about sports? Now guys, observe this. I have 3 statements over here that are talking about sports. Tokenizing. There are 3 words here. There are 3 words here. And there are 1, 2, 3, 4, 5 words over here. So 5, 3, 8 plus 3, 11. I have 11 words over here when we are talking about sports. But I'm interested in this word game. So let me just figure out. The word game is used over here. I don't have the word game here. I have this word game over here. So 2 out of 11 is what is the probability of this word game being used whenever we are talking about sports. So that is how I'm getting this probability 2 on 11. Is this understood, guys? Is this understood? From where am I getting those values? 3 out of 5, 2 out of 5, 2 out of 11. Is this understood? Again, moment you understand the concept, it's done. Don't bother coding me. You'll never be required to do this. The idea is, if somebody is asking you how does naive Bayes theorem work, you should know how exactly it works, because that helps you understanding that what are the things that you can do which can actually affect the frequency or the efficiency of the algorithm. If you don't know this mathematics now, you might end up doing something in your data which will effectively hamper the efficiency of your algorithm. So this is how I'm going to calculate this. So now, guys, understand this. Now, this is a very important point. Please understand this. So over here, so just now I calculated that the probability of this word game appearing when we talk about sports is 2 on 11. So let me just try and put this here. I'm trying to get this. This is my requirement. So game and sports, say suppose it's 2 out of 11. Say close and sports. Let me try and understand. Out of 11 words, how many of them are, how many times have we used the word close? No, no, no. The word close is not appearing. The word very. How many times is the word very appearing? This is 1. just once. So this is 1 on 11. So this is 1 on 11 over here. And then how many times the word A is appearing? A appears here, suppose A appears here. So this is 2 on 11. So basically what I need to do is I need to get the product of all these probabilities and I'll get my answer. Now understand the issue. The issue is this, see this. The problem is that this word close has never been used before when we are talking with reference to sports. Now, guys, understand this. I'm not telling you that this word close cannot be used with sports. It's just that the data set that I'm working on, the database that I'm working on, does not have this word close whenever we are talking about sports. This can always happen. See, ऐसा तो नहीं हो सकता that say even if I have say 1 lakh statements, it's not possible that okay, whatever 1 lakh words statements that I've used for describing something, there cannot be a new way of describing it. Now, my problem here is, guys, understand this. If this is 0 divided by 11, this value becomes 0, irrespective of what happens with all the values. This probability, this product will become 0, na? So even if one of the probabilities becomes 0, gone, everything becomes 0. I'll say that the probability of this is 0. I'll say that no, this statement is not related to sports. That is what we'll say. But guys, understand this. This has happened just because I've used a word which has never been used before with say sports. So I'm saying that no, this has got nothing to do with sports. Don't you think this is absolutely stupid? That just because there is one word which does not appear in our database, that is why we say that no, this cannot be about sports because इसमें एक ऐसा word है which has got nothing to do with sports. It cannot work like that. So whenever we are working with probabilities in naive-Bayes theorem, it is possible that we might encounter certain cases, certain scenarios where the probability of a certain word would be 0. I want to take care of this particular problem, and that is why for taking care of this problem, you will always use something called as Laplace smoothing. Is the purpose of Laplace smoothing understood? How that is done, I'm still to discuss it. But the purpose, why does naive-Bayes theorem use Laplace smoothing? Is that understood? Right? I can't afford to have a single probability as 0 because practically it doesn't make sense at all. Guys, is the purpose of Laplace smoothing understood? How that is being done, the mathematics behind that I'll show you now. And in my code, it will happen automatically. But guys, is the purpose understood? Any doubts with this? A lot of times when I take vivas for college students and stuff, they implement all of Bayes theorem, everything very nicely, and they'll not incorporate say Laplace smoothing as part of their solution. The moment I give them a sentence like this, their entire system, their entire model fails. So guys, you need to be very careful. The class that I'll be giving you in the code, it will take care of Laplace smoothing as well. It's a very important thing. Now, what does Laplace smoothing do? See, it's such a simple funda. See, what I know is that one of these values in the numerator can become 0. And that is what will make my answer as 0. Right? How do I do that? Guys, please understand this. What I do is simple. Whenever I'm taking the values, I will add 1 to it. So I don't care what this value was. I will add 1 to it. So worst case, if this is 0, 0 plus 1, this becomes 1. But see, you cannot just, when you're talking of probabilities, you cannot just do like this, right? You cannot just add value 1 wherever. It'll change the entire value, because whenever you talk of probabilities, when I say probability of A, it is always with reference to B, na? So what we need to do is, whenever we spoke about all the words that are available, there are 14 unique words available in the database that we are working with. Out of which, yes, 11 are related to sports. So 11 are the words related to sports, and there are 14 unique words in our database. So this is the change that I'm going to make. So whenever I'm calculating something, now my denominator is not going to be 11, my denominator is going to be 25, but my numerator is whatever the value plus 1. So that is what we will be doing. So that is how I'm going to be calculating the probabilities. Now, guys, please understand this. I'm looking for both the probabilities over here. For this word A, the probability of word A being used in terms of sports is this. The probability of very is this. The probability of close is this. The probability of game is this. See, when I talk of close, the numerator was 0. It has now become 1. Similarly, what is the probability of each of the words when it is not related to sports? So over here, we will be talking about these two statements which are not related to sports, and we are calculating with reference to that. So we will get that. What I then do is I just calculate this data, whatever was required. I'll just calculate this. I'm getting this value. For not sports also, I'm calculating this value. So looking at this, what I understand is that the probability of this statement about being about sports is this, but the probability of this statement not being about sports is this. If this is A and this is B, what I find is A is greater than B. That means the probability of this statement being about sports is higher than the probability of this not being about sports. That is why I'll say that this statement, a very close game, is related to sports. Is this understood? This is how your naive Bayes theorem is going to work, right? Okay, observe this. I'll just quickly just summarize this for you. See, it's a very simple algorithm, ready-made codes there, but it's a very popular algorithm, very important algorithm. And sentiment analysis is something which is done all the time. See, all those who are college students over here, guys, for final year projects now, if you are planning to pick up say sentiment analysis, please don't do that. See, for my students, I always tell them never use sentiment analysis as your final year project, because agreed that it is very important, it is used widely, but lot of people implement this. And the best part is everybody knows that there are almost for everything you have ready-made codes available for sentiment analysis. You are not required to do anything for getting that. So even if you worked really hard and got a system for me, I'll be under the impression, okay, that any which way sentiment analysis is very common, you get a lot of ready-made codes, you've used just that. So not a great concept to pick up as your final year projects. Engineering students especially, don't do that. Pick up something else from ML, but don't pick up sentiment analysis. It's very favorite for students as well, but a bad choice from your vivas and the examination point of view. Okay, so this is the formula for the naive Bayes theorem. We'll understand this with this example. I have 5 statements, out of which 3 were about sports and 2 are not about sports. I want to analyze this, come up with a model, and then make a prediction about the statement, a very close game, whether this is about sports or not. So for me to do this, first I need to look at feature engineering. Feature engineering is trying to identify what are the words or what are the tokens which are important as far as the processing part is concerned. As far as the processing part is concerned, anything that is irrelevant, or actually they are called as stop words. Now guys, what do you mean by stop words? See, words like the, this. See, these are the words which appear in our vocabulary all the time. But guys, understand this. It doesn't make sense to it doesn't make sense to the system. Suppose if I tell you, what is the price of an iPhone? Suppose this is the query that I'm putting in for Google. See, now what Google does is Google will obviously look at the words and try to understand what is it that I'm trying to search, or what is it that I'm looking for. Now guys, observe this. It'll for it the word which is important is what. See, word like what, where, which, how to, these are important because that will define the things that you select. Now understand, the word is, the word the word of, the word and. Do you think these are going to help say Google in its search? No. What Google actually picks up is just this much. That's it. So when it is searching, if you type what is the price of an iPhone and what price iPhone, will get the same result, because any which ways these words which are always part of the vocabulary, but they are not helpful when it comes to implementing whatever other technical concepts, we will just eliminate these words. These words are called as stop words. So when you go for naive Bayes implementation, you will find that we will have to remove all these words. So what your system does is it will remove these stop words as well, because stop words doesn't make sense. See, whether it is about sports, whether it is about movies, whether it is not about sports, or whether it is about elections, these words will appear everywhere and they honestly don't indicate anything whatsoever. So feature engineering will involve picking up the words and removing stop words. Actually, if you see, when I demonstrate this program will take a lot of time to execute. The reason is feature engineering is where I need to extract out all the words and I need to remove all these stop words, and that is why it will take a lot of time. Okay, then what I do is I need to apply this formula to get my answer. For me to get this formula, I need to calculate the probability of a very close game whenever we are talking about sports. So I need this probability. Now, how do I get this probability? This probability can be calculated like this, but the issue over here is if even one of the probabilities becomes zero, everything is gone. So to take care of that, we use what is called as LaPlace smoothing. What LaPlace smoothing does is, in the formula, it will add 1 to whatever is the frequency, and then the total word count is what is added over here. Using this, I can calculate something like this, and then I'll get my answer. So this is how this algorithm is going to work. Right, guys, I'm done with the discussion part as far as this algorithm is concerned. I'm now going to go to the program, the demonstration part. Right, any doubts with the concept? All this will happen automatically in the background. Any doubts with this? Anything pertaining to this? Okay. Now let me just go to this program. Now, guys, what we'll do is over here. Please understand this. See, we'll be working on a database which is pertaining to the movie reviews. We've taken that particular database from IMDB ratings. Now, this IMDB ratings has ratings for about 25,000 movies, right? It has 25,000 movie reviews where people have rated movies on a scale of 0 to 10. Now over here, I just need to say whether the movie is good or bad. So what the developers have done is they've just converted this particular data. See, I can have so many different values, 1, 2, 3 till say 10. I can have so many values. But again, what we've done is we've decided a threshold of 5. So if a movie has got a review of say less than 5, we will say that it's a negative review, and any value greater than or equal to 5, we'll say that it is positive review. And based on that, we are going to work. Now, this is an actual database from IMDB. Now, yesterday when I mailed you the lecture link, I've sent you another mail, guys. I think last night you would have received 2 mails from us, right? Just confirm whether you've received the second mail. What it is, I'll give you that in detail. Don't bother about that mail as of now. But I guess you've received 2 mails, right? Yes. Now, see, this is because, see, the second mail basically gives you the program that I'm going to discuss now, and also the data set. See, the data set is very big, so I could not upload it on the app. So that is why that has been mailed to you. So whatever data set I'm going to be working with now is mailed to you. You will not find it on the app. See, 25,000 movie reviews, Anna. So that is where the data set becomes huge. So that is what we will be using now. Now, guys, just observe this. I'll go to this program again. See, probability. Yes. See, I'll show you the data set that I'm talking about. Where is it? Just a sec. I'm just. Guys, this is what you will find over there. IMDB review test and IMDB review train. These are the 2 data sets, and TSV is tab separated files. So both these combined, I think it's a pretty big file. So I could not upload it. So I've sent you that. Yeah, almost 63 MB. The files are 63 MB. You can download them later and you can work with that. So they basically have the review. So I'm going to be working on those reviews. Just look at this code carefully. Just understand this. I'll just zoom this up a bit. Please understand what we've done. I'll show you the entire code as well. And again, I'll show you that part of the code which never changes whenever you're working with say Bayes theorem. Now observe this. See, guys, over here, I've started by importing a lot of stuff. Please listen to this carefully. NumPy, Panda, Seaborn, we know all these things. RC parameters from PyLab. RE is your regular expressions that you use. Now, the usual stuff. Then you have Matplotlib over here, math over here. Now, from scikit-learn, we've got import train test. So we've already used this so many times. I think collections are not required. We could have managed this without collections. Now, the two important libraries that I want you all to understand here are, first is, where is it? Beautiful Soup, BS4. Now, what is this? Now, BS4 is that library in Python which we always use for web scraping. All those who were there for my Python course, if you remember, we did something related to web scraping. Web scraping means where you go to the where you can go to the different websites and then you can pick up the data. You can scrape the data from over there. Basically, Beautiful Soup will give you the concept. Will give you the tools which will convert the entire HTML data into text. So using Beautiful Soup, what you can do is you can go to different websites, pick up the data from there and convert it to text. So that is what Beautiful Soup does for us. Then as always, you have accuracy score from sklearn.metrics. I also have confusion metrics and classification report. Now, two important things you see over here: import stopwords from NLTK, and then we have imported NLTK as well. Now guys, what exactly is NLTK? So over here in this program, I've actually used only two new components. One is Beautiful Soup and the second one is NLTK. What is NLTK? Natural Language Toolkit. So NLTK is basically that library which is a collection of almost all words from English language. So whenever you are required to tokenize something, whenever you are required to pick up some data and then classify it into words and then go for analysis or the meaning of those words, then you will use NLTK. So whenever you're talking of natural language processing, you will surely need NLTK. And if you're talking about say data processing, where you'll be accepting the data say from the web or somewhere, then you'll always need Beautiful Soup. Beautiful Soup will do two things for you. NLTK will do two things for you. One, it will help you identify the words, and second, it will help you eliminate the stop words as well. Stop words are something which are not required over here. Now, later on, I'm going to be drawing some graphs. So what is the pattern that I want to use? That is what we have. Even if you don't write the statement, it's fine. What the system will do is system will use the default organization. What is the size of the graph that you want? Random seed 42. Now what is this? See, later on, using this numpy object, I'm going to be generating a lot of random numbers. Now what I want is my random numbers have to start, but every time I run this code, my random numbers have to start say from 42 only. So that is why we put this random seed. So what we've done is we just want a threshold. I don't want a value less than a specific value. Then we will always use random seed. Even if you change that value a bit, it doesn't make much of a difference to your final output. Now, guys, I'll just first demonstrate what this program is. This program also will take a little bit of time to process because there is a lot of data that we are working with, and what happens is that we need to apply Bayes theorem, so it takes a little bit of time for that as well. Now what I'm going to be doing is just look at this initial part. See, first is I'll just open this particular file as always, pd.read csv, right? I'm reading this particular file, imdb review.train and imdb review.test. That is what we've got, and train.head. So when I display this, it will display the first 5 rows. Now if you see, the first 5 rows that I'm getting are these. So you just get an idea that, okay, the file has opened properly. So this file actually has 3 columns. First is the ID, the review ID. The second is the sentiment. One is that it's a positive sentiment, and 0 is that it is a negative review. And then what is the actual review? That is what we've got over here. Okay. Now, once this is done, what I'm going to do is I'm going to draw a graph. Now, observe this, guys. In this particular column called, where's it? In this column called sentiment, you see the values as ones and zeros. So 1 is where the review is positive and 0 is where the review is negative. So what I'm going to do is I'm now going to plot a graph which is going to tell me how many negative reviews and how many positive reviews. That is what we'll do over here. Guys, please observe this. sns.count plot. Count plot. See, whenever I say just plot, it will draw. Whenever I say count plot, it will just get the count and then plot it. What this will do is it will go to this column called sentiment and it will pick up the data from the training data that we have. Now in this column sentiment, there are 2 values, 0 and 1. It will get the count for number of zeros and count for number of ones. And then what I'll do is first it is picking up 0, so I'll give the label as negative, and then and as positive wherever it is 1. So if you look at this code till line number 34, what it will do is it will get this graph for me. It will print the number of negative values, the number of positive reviews. Now over here, out of 25,000 values, exact 12,500 are positive, exact 12,500 are negative. But guys, obviously practically it may not always happen like this. So whatever is easier to understand, accordingly the data has been given to us. But out of 25,000 entries that you have in your data set, 12,500 are positive and 12,500 are negative. So that is what happens over here. So if you ask me, what have I done till say line number 34? All I've done is I've written some imports, I've just opened the file, and I've just displayed the current sentiments that are there in the data. How many of them are positive, how many of them are negative. Now you will actually start with the Bayes theorem. Now guys, observe this from line number 36 to line number 110. This part of the code will never ever change. Now, what is this? Observe this. I'll come to that later. Just look at what this is. I have this class called tokenizer. See, this class tokenizer will do two things for you. Whatever is the data that you pass, one, it will clean that data. When I say clean that data, means that it will remove all the stop words. It will remove anything additional. If you have commas and full stops and question marks, it will remove all that things. And second is tokenize. What tokenize will do is it will take that data, convert it into a list of words, and that is what it will return. So if you see, this tokenizer has this particular function called clean. It will accept the data from you. If the data is required to be converted to text, we've converted it using beautiful soup, right? Then what it does is, using this a regular expression over here, it tries to identify what are the extra characters that you have, or what are the extra HTML characters that you have, and it will just clean that. It will just eliminate that. Tokenize is a function which will accept the data that has been cleaned above, and then what it will do is it will just remove the stop words. Now this line number 46, it appears to be very simple, but it takes a lot of time. Stop words, dot words, English. What it will do is, you have a database which is a collection of all English words. Over there you also have the information about stop words. It will compare all the words, it will identify the stop words and eliminate it, and then it will create a list over here which will return all the words except for the stop words. So that is what it is. If you ask me, have I written these functions? No, I get this as it is, and they will not change even a single word. I'm not required to change in this code. So whenever I'm working with the multinomial naive Bayes theorem, I'll always use this class called tokenizer. So that is what we are getting. Now this is the actual class which will do the job for you, multinomial naive Bayes theorem. Now over here you have this initial class. Second, you have you have this constructor over here which will get the data in the form of tokens. It will also initialize all the classes. Then depending on what is the type of the data that we are working with, they will be grouped. Your fit function, whatever mathematics that we spoke about, everything is happening out here. So whatever probabilities and stuff that we are talking about is happening over here. Then there is one particular class, the function for Laplace smoothing. Then there is one particular function for predicting the results. So this part of the code from line number 34 till this point, this never changes. Actually speaking, this program that I've given you is in fact slightly lengthier, because you can see the subparts of that code. You will get a function which would be a single line, which is for implementing the naive Bayes theorem. You just give the inputs. Obviously all this will happen in the background, but you will never even get to know that all this is happening. You can just give the input and you will get the output, right? So that is what it is. Now what I'll change when I'm designing the system myself is the code that you will see now. What I do is, from the data set called train, I'll pick up what are the values for the reviews and the values for the sentiment. So whatever are the values for the review and whatever are the sentiment. As always, we'll divide the data into 4 parts. Now this is where your model is to be designed. I'll convert the data into x train, x test, y train, y test, and using split. Now if you see, we've gone with a split of 0.2. So what this means is that training data is 80% and testing data is 20%. So you can go 70%, you can go 80%, but generally 70% is the standard one. You just change it to 0.3 and then it becomes the standard one. Now, as always, what we did is, for all the models that we designed, we had a class, we created an object for that, and then we called the fit function. Now over here, I'll do the same thing. For MNB, multinomial naive Bayes theorem, I'll create an object called MNB, and straight away, I'm calling this fit function. As always, your fit function will accept the data and do everything that is needed. So I'm passing the training data. Similarly, once this is done, so entire thing concept, the mathematics that we spoke about will happen in this one line. I've just passed the data, rest everything the system will do it on its own. Now once we've done this, I want to get the predicted value. So whatever is the testing data that we have for X, we have stored it in X test. I'll pass it, and so then the predicted values are in this particular variable. As always, if I want to print the accuracy score, I'll just pass the test data and the predicted values. Now over here, I think when I'm running this, it is giving me an accuracy of 0.86. What this means is that 86% of times the predictions that we were made were accurate or were as per what is required. Now actually speaking, we could have stopped here itself, but if you want to print the entire classification report, just pass the testing data and the y predict values, and then you'll get the entire data as well, right? We'll talk about this F1 score in one of the other algorithms that we'll talk about, that we'll use later. Again, confusion metrics. If you want to display the confusion metrics, just pass your test data and your predicted data to the confusion metrics, and then you'll get your answer. Now over here, see, this is the confusion metrics that I'm getting: actual sentiment and positive predicted sentiment. Now there were 2021 times it happened that the review was negative and it was predicted as negative. 460 times it happened that the review was negative but was predicted as positive. So this is the error, 460 times. Similarly, 262 times it happened that the review was positive but was predicted as negative. So this is error. 2257 times it happened that the review was positive and was reported as positive. So this is what it is. So you can see the accuracy, you can see the actual numbers. So confusion matrix, again, please remember, confusion matrix is not mandatory. If you wish, you can plot it. If you don't want, you can avoid it. So this is where we've created the confusion matrix. Finally, we will create what is called as the heat map. Right, so over here we can create this heat map, sns.heatmap, by passing the confusion matrix. I've just passed the confusion matrix, and then it'll print the heat map for you. Why can't I see that? Okay, so over here what we've done is, because we've passed this confusion matrix, it has straight away plotted the confusion matrix with the heat map straight away over here. So you can just print the confusion matrix and stop, you'll still get the same answer. So that is how you will implement this entire thing. See, I've run this program, it is still executing, I'm still not getting the output. So that is how this program is going to work. See guys, just understand this. All you have to do is pick up whatever is the relevant data, create an object of MNB, pass the data to this, print the classification report, done. This is the base concept. This is what is needed to change, required to be changed whenever you are implementing the naive Bayes theorem. Rest of the code remains exactly the same. This never changes. A single word will not change in this particular code. Before that, this is the normal stuff where you just check the data set, you retrieve the data so that the data can be passed over here. Prior to that, these are all just imports. So again, if you see, this code is actually about what, almost 150 lines, but what I'll be required to write as a programmer is hardly 20 lines. So that is what happens today. If you give me any system and ask me to apply a naive Bayes theorem, what I'll do is it won't take me much time. I'll just take the same program, I'll just change the data set, and my job is done. Also, if you see, when I write my code, I keep the variables as much as possible independent of this program, because what happens is, if I can keep the major chunk of the program independent of the exact values that I'm working with, it makes it easier for me to later on change this program and use it wherever I want. So I'll keep using the same set of variable names, just assign them different set of data, and my codes will keep running fine. Guys, keep a repository ready. See, I have a repository of about 22 ML algorithms which are required at all times. So what that does is, if you give me any question, if I want to implement it, I'll just pick up one of the algorithms, whichever suits my requirement. I'll just pick up one of those algorithms, push the data, and then derive the outputs straight away. So you need to keep this repository ready. All these codes are given to you. You can just, if you want to type, you can type, or you can just copy paste from that PDF file, but keep these .py files ready. So tomorrow when you're designing a system, if you need anything from these, you can directly use them. Just change the inputs given and your job is done. So that is how, see, this is still working. I've still not got the output. Earlier, what I did is, before explaining, I'd executed this program. So by the time I finished, I had the output available with me. It is still processing, right? So nothing wrong when you run this program on your computers. It will take a little bit of time. See, now it is giving me the output, right? Don't be under the impression that there is something wrong with your code or there is something wrong with your system. It will take a little bit of time. This is assuming that most of us don't have a computer which has a very high processing speed. So this is okay. I think my system, I'm working with what, I think 2.8 gigahertz, right? So we all have around the same processing power. So accordingly, you'll get the output.